Good morning, Fancy Meat Computers. How is everybody this morning? Testing, testing. Is my audio coming through? Is my visual coming through? I see I have audio and visual confirmation. Cool. Yeah. Yeah, it's kind of interesting. Like, it seems that pretty much everybody is like, it seems like a lot of people are coming down with like the seasonal cold, you know, not coincidentally a couple of weeks after classes start up and everybody's on campus. Like one of my TAs has got one now, so yeah, I think I had a touch of something on Sunday as well. Maybe it's not the virus, but maybe it's just a cold. It felt like a cold, so there you go. But anyway, it's just kind of interesting, you know. Question, Professor Moore, is it fun doing a PhD? Can I plead the fifth? Is that a question I can plead the fifth to? You don't do a PhD because it's fun. It's fun to be in grad school for a little while, but a PhD is just too long to still be enjoying yourself by the end of it, in my opinion. I'm not the right person to ask to get you excited about doing a PhD. Ask me when I'm finished. Maybe I'll be more enthusiastic about it then. So, I think that's... we don't really have any announcements. Although it's, interestingly, there's apparently a way for you guys to sneak in and get the stream link before I've actually posted it, which is interesting because it means that the general population is going to be able to do it. But I will, like, maybe if I just ignore the problem, it won't be a problem. If we get trolls, then that might be a problem. So, you know, if I see any trolling type behavior going on in the chat, I'll tighten up the rules so that particular leak is no longer an avenue of getting stuff. But yeah, until there's I'm a big advocate of like not worrying about problems like that until they actually present as problems, because you might misdiagnose things as being problems when they're not problems. So yes. Uh, we have our ways. Yeah. Okay. So, yeah. Might as well get moving then. We've got a lot of ground to cover this week, and not a lot of time to cover it in. So why don't we get right to it? When last we met, we were talking about Git, the version control software. In this class, your assignments are going to be submitted through GitLab, so paying attention during this lecture is like practical skills for this course. So, yes. So, what's the point of this again? All of the foregoing repository management stuff is great, but it's likely overkill for many tasks. It's useful to be able to use Git archives to, it's kind of like having like a super save and a super undo that's applied to your very file system, as opposed to, a running instance of whatever program it is that you're running. But once you network it, then you have the ability to send and transmit pieces of your file system to other people, like from the command line, very, very easily, very, very quickly. If you're in Windows, you use a GUI or what have you. But it's very, very good and cool. And it's enabled the open source movement to a great extent. But yeah. So, when you are using a networked repository, there are 3 primary commands that you need to be aware of. Number 1 is git clone. When you create a repository on GitLab, in order to get that repository, in order to get a local instance of that repository, you have to clone it, right? So you'll be required to provide the URL for the repository. You can do it either via SSH or HTTPS. I would do HTTPS because it's fine, it works, whatever. It doesn't matter if it works. You will, however, be required to provide your login credentials. It's very much like your command line logging into the website. In fact, that is precisely what it is. Your command line, your terminal, will log into the website, collect the needed information, deposit it on your hard drive, and then you can use it. And then you can, push the data back and forth. So yeah. Git pull receives commits from other networked repos and checks out the current head. So to receive the information from the rest of the repos in your network, including GitLab, to receive information from GitLab, you use git pull. You're pulling the data. If you want to if you want to save your data to GitLab, you must push. Git push. So yes. So those are your primary commands. Let's see. It's okay if the terminal in VS Code doesn't work. Yes. Yeah. If you haven't got VS Code configured properly, then it doesn't matter. Vote for Pedro. That's cool. Yeah. Oh, yeah, it's election day. Go vote. I don't care who you vote for, just go vote. Yeah. So, a note on URLs. If your repo is being hosted by GitLab or GitHub, they have a handy button you can use to get the correct URL. So this is a snapshot of what the GitLab interface looks like. You just hit clone, you copy this URL address, or sorry, that's the SSH. Copy this URL address with the little copy button, and then just paste that into your clone command and everything will work. It's very easy. So you clone first to create the local instance. From then on out, you're pulling and pushing. Yes. Yeah, you only have to clone once. That just sets it up on. It's like git init, but it sets it up. It initializes it from an external source, but it's otherwise very, very much like git init. After I type git log and I get stuck on some screen that I don't know how to get out of. Oh, just press Q. Just press, like, if your log is long, they'll bump you into a thing called less, which is just a thing for viewing long things. If you can't get out, you should be able to scroll up and down it, but if you press Q, that should get you out of it. When you're stuck on something, first try escape, the escape key, then try Q, the quit for quit, and then, if all else fails, Control C for kill this. What's the difference between committing and pushing? Ah, an excellent point. So you have to commit before you push. So what committing does is it sets up the snapshot, right? Then once you have set up the snapshot is what you're pushing, right? So yeah, I think I actually did a demo of this last time, but yeah, we'll do it again. GitLab. Bum, 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 bum. Example project. So, if I want, so this is a GitLab project that I have set up that I was using, I think, last time. If I want to clone an instance of it, click copy this. Then, wherever you want the wherever you want the repository, I'm just gonna delete this. Git clone paste. Notice how I had to do that with a right-click menu. There we go. Clones the project. I didn't have to enter my credentials because I've already entered my credentials for this for GitLab on this machine. So cd example project, and there you go. That's what's in there. So if I want to add something to this, like file.txt, get it file.txt. I am the very model of a modern major general. Save. If I view the contents of the file using cat, there you go. So the full process for sending this, the entire contents of this repository to GitLab is as follows. First, git add all. Dot means all. If we do git status, that'll show us that this new file has been staged for commit. It has been staged for commit, but it has not been committed. In order to commit it, git commit. That creates the snapshot. You need to include a message. Added a file that was goofy. There we go. Now the commit has been created. If we say git log, you can see that the most recent commit has the message that I just gave it, right? Now, git push. And you can see it says enumerating objects, counting objects, delta compression, compressing objects, writing objects, etc., to this URL, and there you go. So what push does is it synchronizes your local changes to the network, right? And pull pulls changes that are in the network to your local machine. So if I reload this page now, you'll see that file.txt has been added. This is like a view into the into the internet, right? This is not in my local file system. So there you go. I am the very model of a modern Major General. And you can actually edit these files from within GitLab itself. I've information, vegetable, animal, and mineral. Oh, so when you edit the file here, you commit the change, and that's how you save the file. So every time you save the file, it creates a new snapshot. But there you go. So there's our new source file. Go back up to the project. Take a look. It's changed. Going back to terminal, cat file.txt, it's still only got one line. So if you git pull, it pulls the latest changes, and then if we take a look in the file, the changes are there. So the strength of this is that you can have multiple people working on stuff at the same time, right? Like, if it's just, like, it's still a valuable thing to do if it's just you. Like, I keep all of my course materials in these repositories, but if it's, you know, if it's a team of people working on it, you know, one person can be modifying one part of the code, another person can be working on another part of the code, and it keeps track of who's done what and in what order. And, you know, if you need to, you can go through the history of the commits to reconstruct how it works. So, there you go. Yes, git clone creates a new game. Git push is save game. No, actually, I would say git init creates a new game. Git clone is new game plus. Can you always use nano instead of touch and get it? Yes. Why did you add a slash after you changed the directory to the example project? Well, actually, I didn't. So, fun thing about Bash, if you hit tab, it does autocomplete. So it added it itself. It's because anything with a slash is a directory. So example dash tab. Yeah, tab completion is your friend. Touch changes the date modified attribute of a file, but it can also be used to create a file from nothing. Yeah. Get it doesn't work on your terminal for some reason. It might not be installed, but if it doesn't, just use nano instead. Nano works fine. Yeah, you need to have X server running to have get it work. So. How do you submit a file into an assignment? Well, an assignment is just going to be a directory that's filled with your answers to the various questions. There will be instructions. I will be posting the first assignment at some point today, and you'll be able to see the instructions that will tell you how to arrange your directories so that you can submit your files. Everything will be cool. If you delete a directory that has the Git file on it, it will delete it on. Will it delete it on GitLab too, or will you have? Yeah, good question. So the answer to your question is if you delete a local file and then you add, like when you perform the add commit, it will update the snapshot to remove that file. Right? So like there's a special command for it, but I think that's correct. It might also be like git remove. I might be talking BS here. Let me see. Let's see. Well, let's try to delete file.txt. So, rm file.txt, git status. There we go. Deleted file.txt. Oh yeah, okay, so you do have to do git rm. So git rm file.txt. There we go. That will remove it. So add adds and remove removes fairly straightforwardly. And then if I git commit, removed some nonsense. There we go. Git push. Reload. There you go. It's gone. Avenue is down? That's not good. They need to get on that because Avenue is essential. So, okay. Right. So, collaborative workflow. When working on a project with humans, it is courteous to A, always pull the latest changes before you start working. B, always push your changes promptly when you're finished. Document your changes, period, exclamation mark. Communication is key. Any major changes, such as new features, should be made in a separate branch and then merged back into the master when the new feature is mostly complete. So, imagine that you're working on something at the same time as someone else is working on something, right? You want to try to make sure that, like, everything is, you have the latest changes before you start, right? It's not just courteous. It's also good. It means you don't have to redo work that you've already done. How do you change the default directory that terminal goes to? There's probably a setting for it somewhere, but I'm not sure. You could write a script that takes you wherever you want to go from startup. So, when managing a Git repository, we're actually just onto the whole thing on branches, so I'm glad you asked that question. Let me go out on a limb here. It is your job to keep the master branch stable at all times. Generally speaking, the etiquette with respect to Git repositories is that master is expected to work. So if master doesn't work, then people are going to think your project is shit, and they'll be right. So when you're adding features, or even just doing general development, things will often be broken for a period of time. Pushing broken code into master is the height of bad manners. When your branch is finished, you can merge it back into master, often with minimal effort. But so, like, if you wanted to add a feature to a program, you create a branch. A branch is a separate instance of your repository that can be modified independently of the master line of commits. So it's kind of like sandboxing your specific changes until such a time as they don't break everything. And then once your changes don't break everything, you can push it back into master. Yeah. Yeah. Just be careful, Windows users. CMD will bring you to a DOS terminal, not a bash terminal, I think. But that might not be the case any longer, unless Microsoft has abandoned DOS for bash. But I don't trust that would be the case. So, yes. This way, different people's changes remain isolated throughout development. Ignore that apostrophe. So, for example, if I want to do, like, if I'm working on, say, a video game, right? Master is like the finished version of the video game, or the most up-to-date version of the video game. Let's say I wanted to add an enemy to the video game. I would pull a branch off of master. I would work on this particular enemy in this video game, and try not to break the rest of the game, but it's probably going to happen, so I get my own little sandboxed instance to be able to do that in. And once I have my feature to a state of completion, I can merge it back into the main thing, and hopefully everything works. And while I'm working on my enemy that I'm adding, someone else might be working on, a power-up, right? And that person can be working on the power-up at the same time that I'm working on the, at the same time that I'm working on the enemy. There's a whole thing about resolving merge conflicts. Yes, there is. Yes, there is. So, these are the commands. We're going to get to merging a little bit later on. Branching is easy. In order to create a branch, all you have to do is say git branch and give it a name. This creates a new branch with the given name. You will have to switch to the new branch manually if you want to use it. So, for example, I will do some git stuff here. So, let's say I want to add a new feature. Git branch new feature. There we go. Git log. Actually, it's easier if you do git log one line. Yeah, one line graph. This will show us. So, I need to git switch to new feature. There we go. Switched to branch new feature. Git, let's just say I get it some file. Right? Blah, 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 blah. Save it. Git add dot git commit whatever. There we go. Git. So now I have git log. If I view the git log, you'll see I have, a commit for new feature. Now, if I switch back to main, git switch main, I can add another file. So, nano other file, put something else in it, save that, there we go. Git add, git commit, message, whatever. There we go. Git, now if I take a look at the git log, all, there we go. Need the all keyword to see all branches. So, see how I, starting from commit 23f, this guy right here, I now have two versions, right? I have the master version, and I have the new feature branch that I've pulled off of master. So these can now have their own independent chains of, you can branch from branches, you can create very complex structures, but the thing that we want to do eventually, once things are done, is merge things back together. But, yeah, let's see. What's even worse than broken code being added to the game? Adding a broken character to the master compared to the other characters. Yes, broken characters are, yeah. What would be the difference between git checkout and git switch? With checkout, you're also looking historically, whereas with switch, you just have to name the branch, and it'll automatically take you to the head, so it's less fussy. As long as you know what your branch names are, then switch is faster. Cyberpunk 2077 needed this. Yes. Although I think the problem with Cyberpunk 2077 was face conflicts, not merge conflicts. But anyway, or face texture conflicts. Anyway, so I, that's sure. You may notice on GitHub one of your popularity indicators is the number of forks your repository has. So forking is creating a new instance of a repository. It's like it's like a mega branch. So if you have your bitter rival, right? Let's say that you have a bitter rival in like the type of relationship with this guy that Ash has with Gary in the Pokemon show. Like that type of level rival, and Gary starts a horrible, like, it's horrible because it's so good. His code is so good in this repository, and you need his code, but you don't want to contribute to his project because he always says "smell you later." So what you do is you fork that repository. That gives you a copy of the repository that has a separate, like, at the point that you fork it, you now have a separate history. Like, your history and your modifications no longer contribute to the original project anymore. It's like branching, but for an entire repository. And one of the measurements of the popularity of a repository on GitHub, at least, is the number of times it's been forked. Because if it's been forked a number of times, then, you know, people find it useful, hypothetically speaking. Yeah. So every Oblivion NPC was made on the same branch. Yeah, that's probably true, actually. What? Yeah, good. So, yeah. So forking is important to know how to do. If you go to GitLab, let's see here. Clone, maybe. Repository. I don't think I can fork my own repository, but if I look at somebody else's repository, I would be able to do it. But, yeah. So, forking is different from a clone because when you push to the fork, it doesn't show up in the original repository, right? So, if Ash forks Gary's repo, then any modifications that Ash makes, Gary won't see them, right? Whereas if Ash only cloned Gary's repo, if Ash pushed any commits, they would end up in, like Gary would see them. That's how they're different. So, merging! So in order to merge, the syntax is git merge, and then you specify the branch name. Merges the specified branch into the currently active branch. You can see which branch you're in by using git branch. Merging requires a commit message, and Git will prompt you with one with a text editor if it's missing. So in the same way that a regular commit. Merging automatically creates a merged commit after it's finished. Git is pretty clever at merging branches, but there is always the possibility of conflicts. Conflicts are terrible. If the changes are in different files and in different branches, the merger is trivial. If the changes are in different parts of the same file, merger is trickier but will probably work. If the changes are in the same part of the same file, Git probably won't be able to figure it out. So what Git does is it leaves tags in your files that you the programmer, are responsible for sorting out. They look like this. It'll be like this side has this, this side has that. A conflict happens when a branch merger can't be resolved automatically. Fixing conflicts is your job as the programmer. It's tedious and nobody likes it. Nobody likes fixing merge conflicts. That sounds an awful lot like how academic dishonesty happens. Yeah, well, you can also have your, like, for you guys in this class, we are requiring your assignment repositories to be private so that nobody can get in there and clone them. Because you're absolutely right. This is like technology that seeks to enable sharing of code. So we have to, we have to clamp down on certain features of it in order for it to be suitable from the perspective of academic dishonesty, yes. Yeah, all of your repos are going to have to be private. It will be considered a breach of academic dishonesty for you to not have a private repo, to be putting all of your code on a public repo. So anyway, in general, when a conflict occurs, Git puts something like this in the file. It's reasonably easy to find these if you if you know how to search through files for things using grep. But yes, so so we have two branches going on right here, right? So let's say we had, let's say we go git switch back to new feature, right? Let's make a file with the same name as other file. So get it other file, and we'll put something different in it. This should create a merge conflict. Git add, git commit, living dangerously, git push. Fatal, the new branch, has no upstream branch. Oh, well, that's fine. We don't have to push, we can do all of this locally. So, this is what new branch looks like. Now, git switch to master invalid reference. What are they calling it these days? Main. Okay. Git switch main. Right? Now git merge. So we want to merge the specified branch into this one. So merge new feature. Auto merge. Okay, merge conflict in other file. Auto merging other file. Automatic merge failed. Fix conflicts and then commit the result. So we now have, if we take a look inside of other file, we have exactly what I specified. We have both versions of what other file, like other file only had one line in it, right? So if like lines, 1 through 50 matched, then it wouldn't create a merge conflict for those, right? So what you have to do is you have to go in there with a text editor or whatever it is, and actually physically, let's see, I want both of these. That's what I've decided. I want both of these. So there we go. I have fixed the merger. Git push, or git add, git commit, fixed merge conflict, git push. There you go. What does cat do? It just displays the contents of a file. It stands for catalog. So, conflicts, I did that. Conflicts of interest. So, when this occurs, the easiest way to fix a merge conflict is to open up the file in your favorite text editor, which is obviously Emacs, and manually make the changes. This requires you to read the conflicting lines and figure out what the solution should be. If the computer could figure it out, it would have. So it requires you, the programmer, to actually look at things with your eyes, make intelligent decisions about what pieces of code should go and which pieces of code should stay. Do you have a tutorial after this lecture? Oh, yes. So, yeah, Chav sent me a message, and, again, due to the sort of everybody getting a minor cold from having been back with people for the first time in a year and a half, we're going to be having that one online. It's not canceled. It's going to be on MS Teams. So, there you go. Yep. So, once you have resolved the conflicts, or as you are resolving the conflicts, depending on how many conflicts there are, commit and push your changes so that they are fixed for everyone, not just you. Fixing conflicts is a major pain. and many team workflows have conflict avoidance as their top priority. That said, they are inevitable, so you're going to need to figure out how to deal with them sooner or later. Possibly not in this class, because you won't really be working on it with... You won't be working in a team on this class, but yes. Trick is rolling back to previous versions to just look to see what the code used to look like. Even if it's just a fact-finding mission, rolling back to previous versions can be of critical importance. There's a tutorial that's like this morning. I don't know if the room's going to be... The room should be open, but if it's not, whatever. Like the room should be open. Like, we don't have keys to the rooms, so... No, that doesn't mean that we're not having the regular virtual section. We're going to have 2 virtual sections this week. Yes. Yes. It's not really an issue if you're not doing branches. You won't get merge conflicts unless you're doing merge operations. So yeah. Last slide comic. Your computer crashed and you lost everything. My work's on GitHub. It's fine. You haven't committed anything in 3 months. Yes. Right. So, 10 minutes left. That's enough time to get into topic 2. Thank you for your indulgence. It just seemed like the class was generally more interested to get this this SVN stuff out of the way so that we all have some, theoretical basis in it before we get into, how the heck... Okay, so now you did know how you submit your assignment. Now we're going to learn how you program your assignments. We're going to talk about basic constructs in C. How do you go back to older versions of the code? Git checkout. There are lots and lots of these things, but yeah. Okay, so basic constructs in C. Here is a simple C program. A really simple C program. We've done Hello World already in this class. But one thing that we may have noticed is comments. So this is going to be a rundown of basic C syntax. So, yeah, hold on to your butts. How do we roll back to old versions of the code? This is what we call commitment issues. Hey! Yeah. Man. Okay. I bow to your punnery. Okay. So, in Python, Octothorpe designates a single-line comment. If you didn't know, this character is called Octothorpe. In C, we use 2 slashes. You'll find, actually, that the C comment convention is used in a number of different languages, not just the C family. Like, I'm pretty sure that Java comments are in the same vein as well. So, unlike Python, C also has multi-line comments. These asterisks in the middle are just for decoration. You start a multi-line comment with /*, and then everything is a comment until you hit the //. This is a great way of toggling code. This is a great way of toggling code. So, yeah. Here are some guidelines for commenting your code in C. At the top of the file, it's good to indicate the author, the date of creation, the date the program was last modified, and the purpose of the program. Comment each function to indicate what its purpose is. This includes any assumptions about the inputs, properties of the outputs, and invariants that might hold through execution. Comments at the end of each function with something like end of function X make your code much easier to navigate. So, what's a comment? I've never heard of them. Why don't you just stab me in the heart? So, one of the things that you'll find when you're programming in C is that C is much less compact in its notation than Python. A C function will take up a great deal of your screen. Like, to have a C function on your screen in its entirety means it's a very short C function. So it's useful at the end of a function to comment what that function is, because that way you have 2 points of reference for like navigating your code. It's a good tip. Even if you have your monitor in like vertical mode, like I do, it's still terrible. Hypothetically, that can be solved by an IDE, but you know, I will teach you so that you know how to program in plain text. So, preprocessor directives. In Python, we access libraries using import. In C, we use include. Include with angle braces. The ... is the name of the library. You've seen us use this already with include standard IO, stdio.h. This includes all of your functions for taking input, printing output, and file IO, actually, but we're not going to get to file IO for quite some time. So, lines beginning with the octothorpe character are preprocessor directives. Preprocessor directives are processed before the program is parsed. So before the program is parsed, anything that you've included is given to the program for compilation. Star.h files are known as header files. Many of C's most important libraries are stored in header files, or at the very least accessed through header files. stdio.h contains the definition for printf and much more besides. Adding the line include stdio.h to the beginning of each C program should become reflexive. There is probably not a single C program that you will write that will not require stdio.h to be included, so you should just type it by default whenever you start a C program. It's like, if you want to set up a template for it, then you're welcome to do that as well, but, you know, template over like 4 lines of code? Come on. Anyway, terminating statements. In Python, whitespace is used to determine program structure. In C, special characters are used instead. In Python, each line contains one statement, unless they are separated by a semicolon. In C, each statement must be terminated with a semicolon, and terminating it with a new line is optional. You don't actually, like, it's not technically, technically speaking, in C, there's no requirement for tabbing, there's no requirement for new lines. You can write your C program all on one line if you really want to, as long as you've got the correct separator characters in there. Nobody does, because that's a horrible way to program, but it's possible. C is one of those languages where it's like, you can do this if you like. I'm not going to stop you. It's like possible but not recommended. Just like Hunt for Red October. So, being a blockhead. In Python, statement blocks are indicated using the colon character and indentation. This is what the max of 2 numbers looks like in Python. In C, statement blocks are indicated using open and close braces. So, something that's inside of a function is inside opening and close curly braces. Something that's inside of a if statement, curly braces. Is there like a PEP8 for C? I don't know what PEP8 means. Will you lose communication marks if you program on one line? we're going to be using auto-grading for a lot of your assignments and stuff. So if it compiles, then it's fine. So yeah, if you really want to write all of your languages on one line, or if you want to write all your programs on one line, it's up to you. I'm just going to say this right now, though. Don't expect a regrade if it's all on one line. Donut-shaped C code that makes a 3D donut. Ha! Yes. That would be fun. So, in C, white space does not carry semantic meaning. It's like the white space is not part of the program. Like, not only, like, I'm pretty sure you don't even have to include spaces. Like in certain places you do have to do have to have spaces. Like when you've got like int x, like there has to be a space there, or else it's int x, right? So you have to separate your identifiers, but everything else is just for readability. Is there a reason as to why we put curly braces on separate lines? Nope, that's a stylistic thing. There's no reason for it except that it looks better and it's easier to read, in my opinion. Some people like putting the curly brace on the next line. Like they'd have a line just for an opening curly brace here. Personally, that's not my style. You know, I like putting the opening curly brace at the end of the line. So it also makes it fit on the slide a lot better. But if you, like, it doesn't matter. It doesn't matter how you do it as long as it compiles. So this program is the same as this program. It is actually identical. As far as GCC is concerned, this is the same program as this. Now, I would just point out, this is not terribly readable for a human being. This is much more readable for a human being. So, PEP8 is a style checker. Yeah, it's called CPP check. Yep. There's a program that you can use to check your C style called CPP check. Yeah. I think I've got some slides on it at the end of the course, actually, but you should know about it now. So, I'm going to, if you have any further questions about Git and how to set that up, I'm going to refer that to your tutorial. Well, I guess it's the end of class anyways, isn't it? Okay. So, yeah. Anyway. Final thought. It is possible to write terrible, terrible C programs. Just, like, really, really bad. But one thing that's interesting that you didn't have the ability to do before was midline comments. In Python, there's no way to do a midline comment. So there you go. Someone's going to say, you can do that if you use the triple quotes. And it's like, that's a doc string. So, how do you find where your local Git repository is? You could do a system-wide search for your .git folder. It depends on whether you're in Windows or Linux. If you've lost a Git repo completely in your file system, the easiest thing to do might be to just recreate it and remember where it is the second time. But yeah. Are there any other questions? I think I've given myself the hiccups. Why does main take void as an argument? Main takes void as an argument to indicate that it's not taking anything from the command line. So if there are two variables, like your options are either void, which means that this function takes, or this program takes no command line arguments, or you can set up argv, argc, which collects arguments from the command line and feeds them in as arguments to main. So in this case, we don't, like, we're not taking anything from the command line, so that's why this is void. You can actually, you can leave void out and just have empty round braces if you want. But it's more syntactically correct to do void. You also technically don't need int, because if you don't specify anything, it assumes int. But again, it's for stylistic reasons. Just clone it again. Yeah, just clone it again. Yep. Why is there int main every time in C code? Dare I say Python is much simpler because it gets straight to the point. Python is at one time, like, Python is simpler and also more complicated. Like, Python has a main function. It's just implicitly the entire file, right? Like, the way that the computer works is it expects a main, right? Like, it's kind of like C behaves the way that the operating system expects every program to behave. So, like, something like Python has to, under the hood, Python has to behave like C. It just hides stuff from you. So, like, the fact that there's a separately declared main function in C, like, this is what is expected. Like, when the computer loads a program, it invokes main. You know, the fact that Python decided to make main everything in the file, that's a design choice by Python. But yeah. Yeah. Yep, that's true. If you wanted to make, if you wanted to return a float from main, then you could. Yeah. C gives you a huge amount of freedom, but you pay for it because it also doesn't hold your hand. Like, C is not a safe language. Python is considered to be a safe language. In C, you can shoot yourself in the foot. That's, like, you can program something that violates the abstractions of C, right? Whereas in Python, you're not allowed to violate Python's own abstractions. So there. I found it. There we go. Cool. All right, well, that's about everything for me today. So thank you very much, everybody, for your time and attention. Keep it cool. Keep it chill. Go vote today if you haven't already. Because, you know, if you don't vote, you don't get the right to complain. Take her easy, folks.